Okay, let's take a look at this example where I'm going to take this triangle ABC and I'm going to rotate it 200 degrees clockwise around the origin. So the origin, the point 0, 0 on a coordinate plane, that's going to be our center of rotation. We're going to take this triangle 200 degrees in this direction, the way a clock goes. So let's see how we do that. When we have a triangle, all that we really have to take a look at are key points, and the key points are these vertices A, B, and C, right? If I rotate each point, and since distance is preserved, like A, when I rotate it 200 degrees, is going to be the same distance, B is going to be the same, C is going to be the same distance from the center of rotation when we rotate this thing. That means then the relationships between the points, their distances, stay the same too. So that means that when we rotate these points, we can connect them with the segment, because the segment is just the visual representation of like distance between these points. So therefore, if we just rotate the points, we got the triangle rotated too. So let's start with point A, and what I'm going to do is visually see the angle of rotation. I'm going to make this blue. So starting, the origin is going to be the center of rotation, so our rays are always going to start at that angle of rotation. It's going to be the vertex. Okay, so here's like 1/2 of an angle. If I had another ray, that we can measure that with a protractor, right? We have an angle formed. But we need to actually measure a 200-degree angle and then mark that with using our protractor, and then we know which way our second ray goes. Alright, so I'm going to grab my protractor here, and let's see here. So I'm going to take my protractor and I'm going to put the vertex, the center of rotation, right at that middle there of my protractor, that intersection. That's where the vertex is going to go. Since the ray that I made here going through point A, the 1/2 of my angle, is on the 0 line of my protractor here on the left side, then I got to count 200 degrees going in a clockwise direction, starting at 0 over here, so 0, 10. But a protractor only goes to 180 degrees, right? So I could use my ray tool again, and this, if I use my protractor, make a straight line, that's only 180 degrees, right? Lines have an angle measure, or are an angle of 180 degrees, what we call a straight angle. Okay, so how do we get to 200 degrees? Well, A is going to rotate 180 degrees and it's going to map onto this this ray over here, right? So that's just 180 degrees. So then we would have to rotate A another 20 degrees, right? So what we can do is take our protractor, and I'm going to, oh, I can't flip it. Well, here we go. I can flip it this way, and I can measure another 20 degrees if I want to, right? See how this is on the 0 line here? Center of rotation still at the origin, so now I can go another 20 degrees, and there would be a 200-degree rotation, right? So now I can take this and go to 20, because that's my 180 plus 20. There's a 200-degree rotation. Now the other way, instead of measuring two angles, if we're going to rotate an angle that's bigger than 180 degrees, we don't really want to measure twice, right? We can, but another way of thinking about this problem is if we rotate 200 degrees, so I'm going to mark this angle here. So this is 200 degrees right here, right? Then what's this angle here? Well, if we add up both angles, going the 200 degrees clockwise, and then whatever this angle is left over, shouldn't those add up to 360 degrees, right? A full revolution. So then we know automatically that this is 160 degrees, right? Notice 160, that's under 180 degrees, so we could use our protractor and we can measure that. So even though I'm rotating 200 degrees clockwise, what we could do, instead of measuring an angle twice, right, because it's bigger than 180, we'd have to measure 180 and then 20 again. We could turn our protractor and rotate counterclockwise, that what we call the reflex angle. okay, that angle that makes 360 degrees, right? So if we rotate 200 one direction, we could rotate 160 the other way and land on the same point, right? So now I've got my protractor here, and you can see how if I were to measure 160 degrees going this direction, see how that ray that is at 200 degrees is also on that 160. Right, so we could actually measure the opposite angle basically using that 360 concept, and then we can only measure once. So now we have the angle 200 degrees that A is going to rotate on. We don't know how far from the center of rotation A is going to go yet, so that's why we use our compass, right? That's why we make circles, and I'm hoping that you guys are starting to understand the whole concept of a radius, right? As I use my compass and I set a distance, that's going to make us a circle with this distance as the radius. So when I want to copy a distance, let's see here, I think I can flip this way. When I want to copy a distance such as the distance that A is from the origin, then I'm just going to use a compass, right? Because I can set that radius to that distance, and now when I rotate my, let's see here, rotate my pen around, notice where that pen now is going to intersect this segment right at this point right here. Well, that's got to be where A goes, because this is the angle 200 degrees, and this point right here is the same distance from the center of rotation as A is, right? So that's got to be A prime. So we actually found the location of A prime. So I'm going to put a point right here, and now we have A prime. The prime, remember, denotes that it's the rotated point. Okay, so now what we need to do is the exact same thing for both points B and C. So what you would do is with your pencil is draw another ray that goes from the origin through B, right? Because we're going to show the angle that B is going to rotate. All right, so now I'm going to grab my protractor here, and I'm going to measure that opposite angle. Even though we're going 200 degrees clockwise, remember if we measure 160 degrees counterclockwise, that'll get us to the same point. Okay, so I'm going to set the ray that's going from the center through B on my 0 line of my protractor. Now I know that I have to count going 0 from this ray, 10, 20, 30, and go to 160. So I'm going to mark that over here. Here's 160 on my protractor. So I'm going to mark that spot. So notice I got that little mark there, and that's denoting that 160 degree rotation. So I can grab my ray tool and draw another ray. Actually, I can just move this angle through that point that I made, right? And that's how we use the protractor to mark 160 degree rotation. Same thing, notice this little mark that I have here. Well, I'd have to rotate this a little bit because this thing rotated, but see how that's the same thing? So there's my 200 degree, but I did the 160. So B is going to map somewhere on this line here. We don't know exactly where, but again, if I mark the distance, that B is from the center of rotation, right? Set that on my compass. Now when I bring my compass over on this line, see where it's going to intersect? That's where B is going to go. So I'm just going to put a little mark there because that's all that I need. I don't need the full circle. So now that I know B is prime is going to go right here, we have one more point to do. So then you would take your pencil, you're going to draw another ray going from the center through C, and now we have to measure that 200 degrees, right? So we don't know exactly where this is going to go yet. So now I'm going to take my protractor again, I'm going to set it so that my ray is on the 0 line, and I'm going to count 0, 10, 20 back, opening this way again. I'm going to mark on my protractor on my paper where 160 is. Okay, so there's 160, and now I know where my second ray is going to go to do my angle of 160 degrees. So it's going to go through this point right here, right? So that's 160 degrees. C is going to be somewhere on that line. So now I'm going to use my compass again one more time here, and oops. And now I just got to get the radius here for C. Oops, off a little bit. That's got to do it. Okay, so that's my radius for C. So then, again, if I draw the whole circle now, see how much that makes? That's a lot of... It makes it a little more confusing if we do the whole circle, or we could just do that arc. But anyways, here is C prime now. So here's C prime. So now that I have my 3 points located, then I can actually just connect them with a segment and finish off my triangle, right? Draw a straight segment with, if you're doing this on your assignment. Even though we have all those guidelines, there's my triangle. And don't those look the same, right? Just rotated around the center point 200 degrees counterclockwise, which is the same thing as 160 degrees clockwise. Or counterclockwise, okay? Let me show you how to do the exact same thing with GeoGebra. It's a little bit easier with GeoGebra once you get familiar with the tools again. But here's how we're going to rotate this triangle 65 degrees. Oh, I didn't say which direction. Let's just go counterclockwise. Let's go counterclockwise, 65 degrees. So I need to actually put a point right on the origin. That's the center. And really all that we have to do, I'm going to show the angle as we rotate. So I'm going to grab my ray tool. Rays are just like half of a line, so it's going to be in our line toolbox. So if I grab my ray tool, I'm going to click on the center of rotation. That's where my ray is going to start, and see how it's waiting for me to put a point down. So let's rotate C. So here's my ray, like half of my angle, right? Showing the center of rotation here in C. Alright, so now what we can do, and I don't have a protractor in GeoGebra, so how do we get a 65 degree angle? Well, if we look in our angle toolbox, this is our measurement toolbox, we have 2 angle tools. The second one that we haven't used yet is called angle with given size, so we can actually tell what size of an angle we want to make. So what we're going to do is we're going to click on C, being a point that's going to be on like the side of the angle. The second point that we click on is got to be the vertex. So I'm going to click on D now. Alright, so now it's going to make an angle with a size that we want. And we want to go 65 degrees counterclockwise. And I'm going to hit OK. And really all that does is rotates C to C prime, right? That's just a rotated point 65 degrees. That's how it creates an angle and tells us, which way to go. So there is our actual rotation point there, right? If I draw, see how this is 65 degrees, and I draw another ray to finish off my angle, that's a 65 degree rotation. So there's C prime. On paper you would have to use your circle, but GeoGebra does that rotation property, that equidistant for us anyways. Okay, so now really all that I have to do is use the same tool, the angle with given size tool, and watch, when I click on B, that's going to be the point that's on half of my angle, and then I click on the origin as the center. It's set to 65 still, counterclockwise, so when I hit it, it's going to go ahead and rotate B for me. So notice B rotated 65 degrees counterclockwise, so it ends up here. And then A, I'm going to click on A, I'm going to click on the origin. 65 is still set there, so now I'm going to click OK. There's my 3 points. So now this must be, here's C prime, B prime, same as BC, right? B prime, A prime, same as BA, and A prime, C prime, there's the same as AC, right? So there's our rotated triangle right here that just rotated around the origin 65 degrees. Okay? I hope that helped you guys with your assignment. Good luck.